So for the final thing in this section, let's talk about compilation and execution. To create a Java program that can be run on a computer, you must compile your Java source code using it. Wait for it. Yes, the compiler. In compiling the source code, the compiler generates a bytecode program that can be run by the computer's JVM, or Java Virtual Machine. And we discussed this in Unit 1, and again, here's the process. We take the Java source code, we feed it into a compiler, which spits out bytecode. That JVM then interprets or translates the bytecode into object code, which is actually run by each computer. And again, Java is a little bit different from, say, something like C++, because when we write our source code, this bytecode is system agnostic. It doesn't care whether you're on a Mac or a Linux machine or whatever else. The bytecode is the same across the board, but each of those operating systems has their own JVM, or Java Virtual Machine. And the source code, remember, is the .java file, and after we compile it, it's going to be in the same name, but it's going to be in a .class file. So that's how you're going to know that this right here is the bytecode and this is the source code. Okay, so and this is what it looks like in the browser. So you can see here again hello.class and hello.java, and you can see here this is a class file and this is a source file. So source is the human readable format in which you can write and edit, and the class file is the bytecode that's going to get fed into the Java Virtual Machine that is going to eventually get turned into the actual program that gets run. In this chapter slides, all of the code fragment examples can be converted to a complete program by plugging them into the method body of this program template. And when I say method body, I'm talking about right here, this section. You're going to want to get experience practicing typing all this out, because you're going to be expected to do this on the final exam. I can't give you any bigger foot stomp than that. You need to have this program template memorized. You need to know how to do a comment header or a preamble. You need to know how to do public class test with the, or not test, but public class, whatever the file name is, with the opening and closing brace. And then you also need to know how to do the public static void main method right here with its opening closing brace. And then of course you're going to be expected to be able to put in some logic and some program in between that. So practice typing this out. I wouldn't necessarily just cut and paste this every time. Eventually, yes, you're going to want to be able to do that because it's quicker, or you can use an IDE that automatically generates these things for you. But since this is an intro to programming class, you are definitely going to have this memorized. So I think that's clear. You have to have this memorized. Let's talk about identifiers. What are identifiers? Well, an identifier is just a technical term for a name in a programming language. And some examples include class names, method names, and variable names, or class identifiers, method identifiers, and variable identifiers. Just like this. So here you can see the class hello, the method name is main, and we might have a variable called height. And just like writing in English, there are sets of rules that govern how you write your Java programs. So here's some rules for the identifiers that you're going to probably have to know. It must consist entirely of letters, digits, or a $sign and or an underscore. So that's it. Those are the only things that you can use in your variable names. No hashtags, no @ symbols, none of that. Letters, digits, dollars, and underscores. You also, the first character must not be a digit. So you can't have like 1x. You can have x1, but you can't have 1x. So x1 is good. 1x is, well, let's put it in red. Not good. Okay? And then finally, if these rules are broken, the program won't compile. And you're going to get an error telling you that it's an unexpected token or something like that. So just letters, digits, $signs, and underscores, and they have to start with a letter. And of course, Park has their own guidelines on what you should and should not do. So let's take a look at those. Number 1, use letters and digits only. Park prefers that you don't use $signs and underscores. Some naming conventions use underscores for local variable names versus global variable names. But for now, just stay away from the dollars and underscores. Just know that you can use them, just not by style convention. Also, all letters must be lowercase except for the first letter in the second, third, or fourth words. And this is called camel casing. So here's some examples. You have first name and days and month, and you can see that the name is capitalized. You can see the in month, the I and M is capitalized. That's called camel casing because it looks like you got humps, like a camel. The only change to that is when you're dealing with class names, you're going to capitalize every letter, even the first word. And that's how we can tell the difference between classes and methods pretty easily, is that you're always going to capitalize the first letter of a class name. So that's going to have to be something you're going to have to remember as a difference is lowercase for methods and variable identifiers, uppercase for classes. And then finally, names must be descriptive. So this is part of what we call self-documenting code. If you have a variable that's storing the number of students, don't call that variable car. All right, don't call the variable, I don't know, container. Call it number of students. So that way it's very easy to see when you just look at your code what it is you're trying to do, rather than to have to write a bunch of comments to explain why you named a variable that has something absolutely nothing to do with what you're doing. So we talked about variables, but what exactly are they? Well, a variable can hold only one type of data, at least in Java. That's different for different programming languages, but in Java, for example, an integer variable can only hold integers, and a string variable can only hold strings, etc. So how does a computer know which type of data a particular variable can hold? Well, before the variable is used, its type must be declared in a declaration statement. And a declaration statement looks a little bit like this. You have your type, like what type of variable is this, followed by a list of names, and then ending with the semicolon. So you could say, I want integers called x, y, and z here. So we would write int x, y, z, semicolon. And that would declare three variables called x, y, and z of type int. That's a terrible T, by the way, int. So let's take an example of these. So here's some example declarations. You got string first name, string last name, integer student ID, and integers row and columns. Okay. If you're going to put comments in your variable names, notice the alignment of the comments. You should have all of these line up in one nice even row. Don't put slashes over here, then have a name. Don't put slashes over here, then have the name. All of your variable comments should line up like that. I will say that generally speaking, if you're writing self-documenting code, you shouldn't have to do that. Like, it's pretty apparent that first name is going to be a first name. So I would say that this is actually a waste of a comment. Don't waste your time typing that stuff out. If it's something that's a little more complex, sure. But if it's self-documenting, then let it be self-documenting. An assignment statement is a statement in which we assign a value to a variable. So in this code fragment, the first assignment statement assigns the value of 50,000 into the salary variable. So you can see here we declare an integer salary and a string bonus message, and we put 50,000, the value 50,000, into the salary variable. So what is the plus operand doing in this last line right here? Well, we've kind of already talked about that, but that is a concatenation, and it's going to append this calculation right here. So we're going to take 0.02 times the salary and then add it to the string bonus message. So bonus message is going to become bonus equals this $, and then whatever 50,000 times 2% is. So that means that it's going to form a new string. So let's see how much you remember from the last unit on tracing. So we're going to go ahead and trace a short segment of code. Go ahead and pause the video, get out your pen and paper, or you can use an Excel spreadsheet, and build a trace of this program right here. And if you've forgotten what that is, I'll go ahead and help you get started. So here you go, you have your trace, and then go ahead and pause the video and fill this out. And you should have gotten something that looks like this. And for those that are paying attention, you'll notice the underscore in salary up here. You can use underscores instead of commas when you're writing digits, and the compiler will automatically strip those out. So it's just if you need to break up characters, you can use the underscore, but you can't use commas. So you can see here, line 1, we declared the salary variable, but we don't have any value in it, so we have a question mark because there could be garbage values in where that value, that salary is declared. But for now, it's really equal to null. It's not equal to anything. You can see same thing with bonus message here. We don't really know what's in it because all we've done is declared it. And then in line 3, we've assigned the value 50,000. So we put 50,000 in our program trace. And then same thing with bonus message. You can see here that we have 0.02 times salary, which was 50,000. And that comes out to be 1,000. And so our bonus message now stores this value. And then finally, we output the bonus message, and this is what's output. So that's how you do a program trace. Pretty straightforward, pretty simple. You're going to want to be able to do this. On the previous slide, you saw that we had an assignment and a declaration statement. A declaration just declares a variable's existence. So example, we had int salary, and an assignment stores a value in that variable. But what if you want to put both of those things together? Well, that's what an initialization statement does. It consists of an identifier and then the assignment operator followed by a value. So here's some examples of that. You can see here we are declaring the total score variable and assigning it the value of 0. Same thing, we are declaring the max score integer and assigning it the value of 300. So when you combine a declaration and an assignment, that gives you an initialization. So let's compare these two methods. So in the previous slide, we had these two examples. But if we were to do it the other way, it would look like this. And you can see how the initialization statements is more concise than having the declaration and then the assignments. Now, you're not going to always want to do this, and it's okay to use them both in the real world. Just kind of stick to one, but be aware that there are times when you might want to go ahead and use the declaration, especially if you're trying to declare all your variables in one spot and then you don't necessarily know what the starting value is. But I would say that it's generally considered better practice to initialize a variable with a default value when it's first declared. So this up here is the preferred method.